Okay, so this is the week 2. So here is week 2 of safety 1051 22 fall. All right, so just as a navigation pointers, here's our class portal. And these are the announcements, and they're going to change. This is today's lecture right now being announced. This is the second group, sections 2, 4, and 6 at 12 o'clock and so on. And here is the lab. Okay, here, so we can just do the announcements here. Now, the video that you're going to watch is from last year, so please ignore any of the logistical announcements that have to do with when we are going to do the labs and there's no labs or there will be labs. Ignore all that because this is from last year. This is right now. So lab 1, I just put an announcement. Keep checking these announcements. That's important because that's what keeps us all together. Now, lab 1 for weeks 2 and 3. We are presently during week 2, and so lab 1 will be conducted during the span of weeks 2 and 3. Just make sure that we are on. Okay, lab 1 scheduled for lab 1 is scheduled for the next 2 weeks. Week 2 started September 12th, which is today. And so when I announce the weeks, I just say the weeks from Monday to Friday. Okay, and week 3 is going to be September 19th to September 23. Make sure that you know which section you belong to. Okay, if you don't know, please go into the. Actually, I'll show you. And if you still don't know, please by all means send me an email. Okay, locate your lab 1 section. So who's first that is going to do the lab today? Oh, I mean this week. This week, the first lab, see here, this is the table. The first lab is going to be done with section 5, and it is going to be on September 14th from 4 p.m. till 6 p.m. with Mrs. Hashemi. Okay. Then for section 5 for the next 2 weeks, that's it. Who else? Section 4 is going to have a lab on Thursday, as well as section 2 is coming to the lab on Thursday. Section 4 is from 1 p.m. till 3 p.m. and section 2 is from 3 to 5. Then section 1, when do we have for section 1? Okay, so it's Thursday, September 22nd from 3 to 5. And section 6 is going to be on Wednesday, September. I just did a little bit of a snapshot of the whole schedule that is posted. Where do we see the schedule? We go to content. Just make myself look like a student so I can show you what you're going to see. So we go to, here's our main class portal, go to content and student items right here. So click on that just to bring it on the main screen. And you might want to, if there's anything expanded, just collapse so you can see the nice and clean menu. All right. So sections list is here. Click on that and click on the PDF file. You can download that if you wish. And here is the list of all the sections by names. Okay, so I'm going to go back to the main class portal and go again to content. Excuse me. Student items. Just bring it here. I'm going to collapse this subfolder and labs. Okay, labs. Click on the labs. Lab timetable. Kaboom. All right. And lab timetable for 10/22 fall. Click on that. And here is, oh, that's what I took the snapshot from. All right. So by date, by section, by times, you have the labs listed. One more thing. Let me go back to the main class portal. I always go back just to show you every time. So, okay, content, student items, yeah, bring it here. Again, everything is nice and clean. Okay, labs, there you go. And here is lab 1. The list will populate as we go along. So lab 1, and you can just click on that. Please download this and please print it when you come to your lab. We also will need your rubric for the evaluation. So please familiarize yourself with the rubric, what we will be evaluated on. All the details about what you're going to do in the lab are here. Plus, we are going to give you a quick demo before you do it. We will do it together with you during the lab, okay? Make sure you bring the tools. Which tools do you bring for this lab? Here is the list of tools. Okay? So the cable is going to be provided for you. Everything else you bring for all, okay, and the duplex receptacle will be provided for you. Everything else you bring, wire strippers, the needle nose pliers, the, well, I just have one kind of a combo screwdriver, but basic screwdrivers, you will need green Robertson, which would be number 1, number 2, red also, and you will need, well, flat, not a flathead. See, I keep calling that slotted screwdriver, which some people call it flathead, which is wrong. Okay, and you will need the side cutters or wire cutters. That's only. Please print those sheets, bring them with you, so you can follow the instructions as we go along, and we will help you out along as we do this. But please do not forget to look at the rubric just to see what you'll be evaluated on. All right, so this is as far as the labs. Cool. All right, now when it comes to the video that I'm going to point you to watch today, it is about an hour. But first, well, okay, first things first. Let's go back to main class portal. Right in the announcements section, if you scroll down, these are going to keep changing. This is like a fluid kind of a screen here. So right after this lecture, I'm going to erase this announcement. All right, just so we don't have the pollution going on in the announcements. So lab 1, here you got the announcement, and here is our YouTube playlist. Okay, this will also keep populating. So let me just click on that. Here's the link to our YouTube playlist. I'm going to click on that. And there you go. See, these are all the lectures that we have done so far. And we're going to keep adding. I'm going to put that as well here. But this is the video that I'm going to ask you to watch. And there's going to be also a second part. And once you watch that, you will actually understand why I'm doing this while I'm pointing you to that. Okay, simply because the setup that I had allowed me to explain things so you get the full benefit of the topic. All right. Plus, if you have any questions, you can ask me either next time we see each other or by email. I will clarify everything for you as best as I can. All right, so this is going to be the video that you're going to be watching. All right, now, before I send you to watch that video, I'm going to have to explain some basic concepts here. Now, let's see if I can. Okay, I'm going to stop sharing and I'm going to call a whiteboard. All right, so just bear with me. And where's the whiteboard? I just had that breakout rooms. No, share screen. Oh, I love this Zoom. I was just doing a practice session, and we had that screen, chat, participants. No. Breakout rooms. No. No. I suppose I can't because the whiteboard just disappeared on me. Chat. Looking at this thing. Share screen. We stopped sharing the screen. screen, no. I suppose the whiteboard can't be shared if I security. Okay, what if I unpin myself? Remove pin. Oh, the whiteboard disappeared. Okay, so there were, how can I do this? All right, so while you are watching this video, I'm going to record another couple minutes explaining of basically this, explaining the concept of series and parallel connection. And I'm going to explain the ranges to you. All right, so actually, you know what? Maybe I can do something else. I'm gonna share the screen here. Share. All right. Yes, I'll do that. I can do this. I'm going to call up a Photoshop. And I'm going to use that instead of the whiteboard. Okay. Stop sharing here for a sec. And I'm going to pin myself here so you can see me. And where is my screen share? The beauty of doing things online. All right. Now, file, new. There we go. All right. Can you see the big wide? Can you see the big white screen right now here? I suppose you can. All right. So let's see the. I'm just going to grab a pen and I'm going to. Oh, is that a pen? No, that's not a pen. There's. Can I do this? Oh, that's why. Here's a pencil. All right. Let's get a thicker line here. Okay, that's good. All right, so let's get the concept of a series and parallel connection. You will be very comfortable with this thing as you go along, but just in case you are not, I'm going to give you the little bit of a rundown of what I'm going to be, the terminology I'm going to be using. Let's say we have something that's called a resistor. Here is a symbol of a resistor, and we're going to call this thing R1. Okay, and let's say we have another resistor that is also going to be R1, well, R2. Okay, whatever the value of the resistors are, values of the resistors are, doesn't matter. Okay, so here is a terminal for the resistor, here's a terminal for the resistor, and these are the connection points. And let's say we have a power supply, DC power supply, direct current, which means the longer prong on the drawing is the positive side, and the shorter prong is going to be always the negative side. If we connect this circuit as such, so we go from the power supply to the resistor, first resistor, then we go to another resistor, and as we go along, we are going to come back to the power supply. So now we have something that's called a closed circuit. Okay, how is the current going to flow? There are two types of current flows you're going to study. One is called so-called conventional current flow, or also it is called positive current flow. And in that convention, or in that setting, we assume that the current flows from the positive to the negative side of the power supply. So this is the direction of the current. And for the most part, you're going to study the circuits this way. Now, when sometimes what you're going to do is you're going to calculate the circuits in a little bit different way. You're going to use something that's called an electron flow, which means that the electrons are flowing from the negative part of the power supply to the positive side of the power supply. And this is yeah. So this would be I'm trying to draw. Yeah. I suppose I can't. Oh, that's why. Okay, and this would be the direction of something that's called an electron flow. Now, when it comes to calculating, and you will be presented with that concept in other subjects, I'm just giving you heads up. When it comes to calculating the circuit, it doesn't matter which way you're going to choose, as long as you keep the same concept from the beginning to the end of your all calculations, and you're going to end up with the same results with the same voltages. It's just you're going to have the arrows pointing which way the current flows in different ways. Okay, so now let's just yeah, and here. Okay, so forget about the current. Now, the connection between these two resistors is called a series. All right, this is a series configuration, that these two resistors are connected in series. Right? Now, if you take the same two resistors, and let's say we erase those lines here, and we erase those lines here, and we erase that line right here, we still have the same two resistors. If we connect the resistors in this way, this is resistor 2. No. That's resistor 2. Now, if we connect the resistors as such, when this part gets connected here, all right, and this part gets connected right to this terminal of this resistor. These two resistors are connected in parallel, and we just grab the connections from any of those resistors. Now these two resistors are connected in parallel. If you rearrange the whole thing, it's going to be the same as, just going to erase this whole thing. If we have the resistors, there's R1, And here's another resistor. It's just going to be the same thing, but drawn a little bit different. R2. And if you connect them like this, and if you connect them like this, and the power supply is going to be right here, plus, minus, here, and here. Okay, so now these two resistors, R1 and R2, are connected in something that's called a parallel. Right? See the difference between series R1, R2. These two resistors are connected in series. These two resistors are connected in parallel. Right? So this is the difference between connecting the resistors in parallel and series, or any kind of components. Right? Now, when it comes to connecting the two basic concepts I'm explaining in that video is connecting a voltmeter and connecting an amp meter. The voltmeter measures voltages, or measures voltage, and the amp meter measures currents, or current. So let's say we have two resistors connected in series. All right. Notice I'm assembling the current flow first. All right, here's R1, and here's R2, 1 and 2. Okay, so here is positive, here's negative side of the power supply, and here is our voltage DC. Okay, power supply. So let's say we want to measure the voltage across resistor R1. How are we going to connect the voltmeter? We are going to, let's say this is a symbol of a voltmeter. We are going to connect the voltmeter in what kind of configuration? It's going to be a parallel configuration. So when we are using a voltmeter, we are connecting that in parallel with the load. Right? Now, in this case, something that's called the internal resistance of a voltmeter, it has to be as huge as possible. Because, for example, if let's say if the voltmeter doesn't exist here, it's not connected, what is connected in parallel with this resistor? Well, you might say nothing, but I'm going to say, well, we have the air, okay? And the resistance of the air is so huge that for this purpose is going to be considered, just insignificantly huge. So the idea is that we are going to take the measurement without affecting the circuit. That's the whole point. Take the measurement, but once you connect the measuring equipment, you're not supposed to affect the circuit. You're not supposed to change how it behaves. You're just tapping in with the measuring equipment to see how it behaves. All right. So if this resistor has a certain value of resistance, and this resistor has a certain value of resistance, and this has huge, almost like infinite, because the air is, for our purposes, considered it does have some huge resistance. It's measurable, but for our purpose, we're going to assume that this is the infinite. So it's just like you're going to try to have it so the circuit doesn't notice that something is being connected. So if this thing is so huge, this resistance is so huge, then this resistor is not going to notice that, right? So what happens when we provide the resistance that's a little tiny bit less than infinite, then we're going to still have a little tiny bit of current flowing through here, just enough to trigger the measuring element of the voltmeter, and it's going to come back here. So which means this current, this main current in here, in this resistor, is going to be slightly less But the idea is to have that, to have such huge resistance that this current is going to be very little, that it's not going to be noticeable. Right? So the idea of connecting a voltmeter is you connect that in parallel with the load, and the internal resistance naturally of the voltmeter is huge because you don't want to affect. It has to be incomparably huge, so that little tiny sample current is such a tiny itsy bitsy current that it's basically it's not noticeable. Right? I repeated this thing a couple times, so if you still have some questions, please by all means. And it is going to be on that video that I'm pointing you to. Now, when it comes to connecting an amp meter, which is supposed to measure the current, the amp meter, we are going to connect in series configuration because we are supposed to measure the current. So here is the symbol of an amp meter. An amp meter measures current. So when the current flows from the positive, assuming the conventional current flow, it's going to flow through this whole circuit. It has to flow through the amp meter, and it is going to flow back to the power supply. So the circuit is closed, the current flows. Now, again, the idea of taking a measurement is to make sure that we do not affect the circuit. So while we wanted the resistance, the internal resistance of the voltmeter to be so high that it's basically close to the resistance of the air, which is infinite for our purpose. Now, in order for us to not affect the circuit, it's just like if we didn't have the amp meter here, we just would use a wire, which for our purpose is considered to have a zero resistance, a piece of cable, a piece of wire. Right? So the amp meter's internal resistance is supposed to be as close to zero as possible. So it just passes the current, and well, it's going to have a little tiny bit of resistance, tiny bit, very microscopic resistance, just so the the measuring equipment notices that and is able to do something with it, right? But the idea of that is the amp meter is supposed to have the resistance as close to zero as possible. So when we plug it in series with this whole equipment, this whole circuit, it acts like a wire. It's not affecting the circuit, right? So that's the idea of series and parallel connection, the difference between these two, and connecting the voltmeter versus the amp meter. Now, the other thing I'm going to ask you to understand is, for example, connecting something that's called a ohm meter. An ohm meter is supposed to measure a resistance. Let's say we have a resistor here, okay, that is not connected to anything but something that's called a ohm meter. And here's an omega, Greek letter omega. We're connecting that to this resistor. How is it that the ohm meter measures the resistance? Well, an ohm meter uses the internal battery of the multimeter to introduce a little tiny bit of a voltage across its terminals to make a little tiny bit of current flow through the part that we're measuring. And based on how it behaves, the internal circuitry is calculating the resistance of the resistor, and it's giving you that thing on a display. Okay. Which brings me to a next point. If you want to measure the resistance of this resistor, let's say, okay, let me just do another circuit here, another small circuit, just so we don't get the mess here. Yeah, we have two resistors in series, and just for kicks, we have another resistor here in parallel with the first resistor. So R1 here, R2 here, and here's R3. So R1 and R3 are connected in parallel to each other, and R2 is connected in series with the combination of the parallel connection of R1 and R3. Let's say we need to measure the resistance of this resistor 1. Okay. So we take an ohm meter, and we connect this across the resistor. Right? Wrong. Well, we're half right. First of all, remember when I said that the ohm meter is introducing its own voltage, and it's creating its own current through the part that is being measured, that is measuring. But what happens is we already have something happening in the circuit. There's a current flow, and when the current flows, it causes voltage drops on certain parts, and we're going to have certain voltage between these points already existing. We're going to have certain voltage across this resistor already existing, because as long as we have a current flowing through a resistor, we're going to have something that's called a voltage drop, which means there's going to be, if we put a voltmeter between this point and this point, we're going to have a certain voltage. We're going to, if we connect the voltmeter between this point and this point, we're going to have a certain voltage. So we're going to have a certain voltage already existing, and then we're going to connect a meter that already also is introducing its own voltage. So those voltages are going to conflict with each other, and probably this voltage right here is going to be much stronger than that one. So it's going to overpower the meter, and chances are that you're going to damage the ohm meter. So what do we have to do? Well, we have to take this part that we're measuring out of the circuit. So I'm going to erase that line for now. I like that Photoshop better than, than the whiteboard that was on the. Okay, so here is. Oh, let's not do that yet. Okay, so we have taken this resistor here out of. We have to break the circuit. But first, before we do that, we have to de-energize the circuit. So basically, we are going to open the switch if it exists, or just disconnect the power supply. So switch is open. There is no current flow. Well, usually you would do it on the positive side and the negative side, but I just did that here. Okay. Actually, you know what? Let's just do it the proper way. I'm de-energizing the circuit. This was supposed to be the preamble before the video, and I'm giving you part of the whole lesson. Not really. I just want you to understand certain concepts. So we de-energize the circuit, so we have no current flow. Right, this is still connected. Can we now measure the resistance of this resistor R1? Sort of. But look what's happening here. There is no current flow in the whole circuit, because the circuit is de-energized, the switch is turned off, the circuit is open, it's not closed, right? There's no closed loop. But if we want to measure the resistance of this resistor R1, are we really measuring the resistance of resistor R1? Well, not really. We're measuring the combination of R1 and R2 because these are connected in parallel. The total resistance of these two resistances connected in parallel is going to be different than the total resistance of just R1 by itself. And how it is going to be, you're going to get that in the DC circuits, or you can just start studying on your own. So it's going to be so much easier when you get to the topic. All right, so what we have to do is we have to disconnect the circuit, the circuit disconnect. We have to disconnect this part. We have to isolate this part. How do we do that? I'm just going to erase that line here. We're going to have to disconnect one side of the resistor. You can take the whole resistor out of the circuit, but for the purpose of measuring resistance, you only have to disconnect one side of it. And it's commonly called as lifting one leg. So one leg is lifted. So now this resistor here is sitting all by itself. And now we can connect this ohm meter to this resistor. Excuse me. I knew it was coming. I was just trying to call it. Anyways, what is this? What's the current flow with the power generated, little tiny bit of power generated by the ohm meter? Well, it's just like a power supply. So the current is going to flow from the positive side of the ohm meter, and it will have nowhere else to flow because nothing else is connected to this negative except for the other leg of this resistor. So how is the current going to flow? It's going to go from here, keep going through this resistor, and it's going to come back. So that's the way the current is going to flow, right? So now it is important that we de-energize the circuit, because if we don't and we lift one leg, we can still measure the resistor with the ohm meter, but the current in the whole rest of the circuit still flows, and it's not flowing through these two resistors, it's just flowing through that one resistor, goes through that one. So sometimes when you remove a part of energized circuit, you're going to create enough imbalance in the whole circuitry that you can actually damage the whole device, right? So it's important to de-energize, lift one leg, and that's how you measure a resistance. This information that I just gave you is going to help you with all other subjects. All right, so here are the concepts that I gave you, and what you're going to do is, let me just, here's the Fansha Online. Here's our class portal. Oh, wait a second. I get another concept here for you. Erase the whole thing. Now, let's say we have a object. We have an object to measure. Let's say it's in the shape of some sort of like a square, maybe, or something like that. And you know that this object, let's say, you can probably tell that it is maybe 3 feet somewhere close to 3 feet. That's the approximately 3 feet. You can just eyeball it, but you want to measure this side from here to here. Let's say you have a ruler. This is a ruler. That's 12 inches. If you just had one measurement to take, could you measure this long side of this object with a ruler that is only 12 inches? Sure, you can do it like through time, 2-3 times, and you can add things. But let's say you have only one measurement to do. Can you measure this long object, side of the object, with the 12 inches ruler? You can't. That is too short. You need a ruler that is longer. You need a ruler that, let's say, is I don't know, 5 feet ruler. Can you measure that? That side with the 5 feet ruler if you have only one measurement? Now, yes, you can. So same thing with the meters. What meters do is they have ranges. It's just like the rulers. So let's say there's a dial on the meter, okay, and let's say you're in the volt section. There could be a current section, there could be resistance section, and so on. But let's say from here to here is the measuring the voltages. And here is going to be one setting, here's going to be another setting, here's going to be another setting, and so on. Let's say this is a 5-volt range. Let's say this is a 20-volt range. And let's say this is a 100-volt range. And you have a circuit that you know that, let's say, there are 2 resistors. Here's a power supply. Okay, and you want to measure the R1. Here's V, power supply. We want to measure the voltage across R1, and let's say this power supply is 50 volts DC. Okay, so you don't know what the voltage is going to be across this resistor or across this resistor. They're going to be whatever it is here and whatever it is here. If you add these two, you're going to get 50 volts, but you have 50 volts. So how would you start with measuring the voltages? Well, let's say, this is going to be somewhere maybe approximately 10 volts across this resistor. According to the calculations that you do, you calculated that the voltage across this resistor is going to have a value of 10 volts. Which ruler or which range you're going to set on the voltmeter to be able to measure 10 volts? Can you use the range that says you can measure the voltages up to 5 volts, or you can't? Because if you have a range of 5 volts and the range is just like the ruler, it's telling you that the way it is set up, if you set this thing to 5 volts, this dial, the meter will be able to measure voltages only up to 5 volts. And this is 10 volts, so you're not going to get a measurement. So you're going to have to switch to the next one. Hopefully it's close enough to 10 volts. Well, it has to be bigger than the measuring value. So you're going to switch that to the next range. You're going to pick up a longer ruler so you can measure that. All right, so switch it to 20 volts, for example, on this one. And then you can measure this voltage here across the resistor, and it's going to actually give you some voltage. It's going to give you some number on display. Now, can you set this to 100 volts range? and get some sort of measurement? Yes, you can. But the measurement on the display is not going to be as accurate as if you choose the 20 volts range. You should select the range that is bigger than the measured value, but it is as close as possible to the measured value, which in our case, if you have this meter that says 5 or 20 or 100, then you would choose the 20. On an analog meter that I'm going to explain on the video there, we're going to have ranges also on the analog meter, and we're going to have needle that basically swings out and points. So this is 0. Let's say this is 0 to 5 volts. This is 0 to 20 volts. And this is 0 to 100 volts range. So depending on the dial on the meter that you said, if you're measuring 10 volts, you would, if you set the meter to 20 volts, the needle is going to swing out about here. Right? And the scale is divided and is giving you the details on how accurate you're going to measure this. Now, this is also going, so let's say this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, so you can measure this 10 volts. You can probably tell it's going to be 12.5 or something like that. Now, let's say this scale of 0 to 100 is going to be 10, 20, 30, 40, 50, 60, 80, 67, 80. It's like every 10 volts. Okay. If you choose that volt, the needle is going to swing only about here. And you're going to be able to tell that, yes, it's about 10 volts, but you don't know if it's 11 or is it 10.5. This scale is going to show you more accurate reading. So the idea is to select the next biggest value, but so it's as close as possible so you can swing out the needle as far as you can towards the end. Okay. So that's as far as ranges. So we have covered here the basic idea of the difference between series and parallel connection. We got the idea of how we connect the voltmeter and the ammeter, series or parallel, in the circuit and why. And I have explained the concept of ranges. So with these three concepts that I just explained to you, it is going to be much easier for you to watch the video that I'm going to point you to right now. And here is our class portal. Again, you go to, well, you don't go anywhere. Here's our class portal, right? Here is our safety 1051, 22 fall. You go scroll down until you find something that says our YouTube playlist. You click on that link, it's going to take you straight to our YouTube playlist where we have our videos listed. All the lessons I'm putting. This one is going to be just before that one in a few minutes. Okay. So you want to see the safety 1051 21F week 2, which is right now lecture 2A, multimeters part 1. And on, I think next time we see each other, I think it's Friday or Thursday, I'm not sure. We're going to cover the second part of the multimeters. So on your own time, because this class is pretty much almost ended, you're going to spend some extra time, but this is just in the beginning, okay? Sometimes we need to spend a little tiny bit extra time. Watch that video, this one right here, and we're going to see each other next time. Are there any questions about anything that we have talked about today or anything else when it comes to this subject? See the chat line here. Nobody's typing anything. Nobody is What textbooks should we bring to class Thursday? We have no textbook for this class, for this SFTY 1051. There's no textbook. Okay. All right. Okay, so now you know what to do. It's sort of like a homework that I'm giving you, is to watch this video right here. All right. I will see you next time, guys. You're wonderful and all that stuff. I read it in the book that I have to say it to you. Okay, see you guys. How do I end this thing? Stop share.